Okay, so I'm changing this basically. The first thing I'm going to do is say that we're going to start with basic triangles, um, because it was first of all right triangles, and I realized it's just a pain in the ass to do that. Um, so the first thing I did was do what's the area of a triangle, because that's generally what we did. So we draw a box basically, and then you see that it's all just divide by two of a box, which is the n. Um, did I ever explain how to get that box? Yes, I think over here. Well, I should probably explain the area of a rectangle is height divided by height multiplied by uh width. Um, New equation A equal BH. Uh, Length. Because I don't think I ever explained that, did I? Yeah, I don't think so. So we're doing it right now. Oh, my tablet slipped. Anyway, length multiplied by width. Anyway, there we go. That changes nothing, but uh, it changes that I have explained it before, which means I'm probably gonna have to show it up over here. Yeah, I'll do that later. I didn't realize I didn't explain how to get a rectangle area of a rectangle. I should explain it here, so it should be good. But basically, you can see the rectangle here, and you just divide it by half. That's how you understand that the area of what the hell did I write there? Why do I have to do this to myself? um, Area of triangle. Why do I make such a stupid dumb mistake? Okay, should do a trick. Anyways, this should fix everything up. Can't believe I made that mistake. Pretty dumb of me, honestly. Oh no, I would have. Well, you know what? We're just gonna cover it up. There. Like nothing has ever happened. I'm not fixing that shit by making that whole thing again. Alright, probably should have just done it in latex so I can easily just code fix up the code. Whatever. Last time I forgot to write about the hypotenuse. Hypotenuse is the longest side of a right angle triangle. I can't believe I didn't write that anywhere. And the leg is the one of the two sides. The leg is less important, but the hypotenuse is used a lot, so I can't believe I forgot to write about that. Then again, oh yeah. So then again, we have all these things uh, discovered by a lot of people. So yeah. Anyways, I need to figure out who the first one wrote it. I couldn't figure it out, so I wrote everyone. I will eventually figure out who the hell is the first person to make this stuff. It might take me forever, but when I have time, I might need to take a class on like math, history, or physics history, whatever, on some of this stuff. Because it's taking me forever to figure it out, and I don't have time for that shenanigans. Um, Anyways, sine opposite hypotenuse, so like this and this over h. You can figure it out from this. Um, we have the common right angles. So basically, these are scalars, so these are just numbers. So angle equal 2, then you just put 2 over here, and 2 square root of 2. You get these, and then I mean, it's just a scale. Why do I have these? It's because for some reason I get those a lot. So if you get a rectangle and divide like that, you always get something like this. And this one, think of a triangle that is 60, 60, 60, and put a stabilizer here, and then make it like this for some reason. And you can kind of see that a lot of these 30, 60, whatever triangles keep on appearing forever. I made this smaller because at this point, actually, I realized the unit circle is useless. I have never used it in my life. I basically used a fucking calculator every single time. I grab my graphing calculator and plug the numbers in and finish. I don't even touch that anymore. Next thing we're having over here is prove this. So we're proving this stuff. Which should. Why do I keep on making mistakes? Oh, my memory shit. Looks like. Anyways, so we have a right triangle as the basis of all sine and cosine, basically. And then we see the arc version that gives you the angle. We finally define that here. Unless I didn't explain it. Did I? Oh, I explained it over here. Okay, thank God. I'm not going senile. Anyways, we know the Pythagorean theorem. We divide by c on each one, and we understand that if we divide by c, this is by definition 1. Uh, I don't know why oh yeah. What the hell is wrong with me? Alright, I just don't leave it in there because, if you're gonna waste space, at least waste it correctly. Right? No, I see why I wasted space. Alright, and then you do all this so you can get different forms of it. And one weird example I just gave out here is this one. Basically, you use the fact that cosine square theta plus sine square theta equal 1, and you plug this into a. So this is a squared now, plus sine square theta, and then you keep on getting into here. Why I did that just for fun. It's an interesting problem. Do I think there's any use for it? Hell no. I couldn't find any use for it. I mean, why would I ever need that? I do not, absolutely have no idea. Like, why? Just why? It's pointless. Here's another pointless thing that's kind of I have never used in my entire life, but you can use it. I mean, you need to know it. I mean, might as well know it, right? But similarities, congruous I use, but similarities. So basically, if you know proofs, you can get similarities by getting two angles of a triangle that's the same. I have never used it. I don't know why I have never used it yet, but yeah, I guess all the way I use it, the proofs is already known, so I don't really use it. I don't know why. Um, anyways, now I keep on blabbering now. Side, side, side. If three sides of one triangle matches three sides of another, the triangle are congruent. Blah 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 blah. Same with each one. Just this one is a special case of this one, which is side angle triangle. If that's true, then this is. If this is true, then these two must be the same triangle. If for huh, I hate when that does happen. Okay. Anyways, this must be true. All right. That's good. That's good. That's good. That's good to hear. Now, if it's a right triangle, if you know one of the legs and you know one of the angles and you know one of the hypotenuse is the same as this one, well, then it's a special version of SAS. Angle, side side, it's just off. Usually when you have something like this, which is a side side A, you can't figure anything out unless it's a right triangle. You can figure out congruence from that, but and where does this? I'll explain where this comes from. I give a short proof over here. Nothing special, nothing biggie. Just a small proof to explain why you would ever need this. 9 out of 10 times, what happens is very intuitive. And oh no, I actually have used this before. Yeah, I have used this. This is the only thing that's useful. I have used this. Oh, yeah, I forgot about it entirely. So if you have a beam like this and it's undetermined, but you know the displacement is like this, you can use similar triangles to figure out uh, how much it'll shift and how much the torque and yeah, stresses and things of a beam. I forgot I used it there. That's interesting. Yes. Okay. Fine. I used similar triangles before, and congruent triangles. Yeah. Okay. Fine. Out of all of this, I have used AA. AA so far is the most important one. Other one, fuck it, I haven't used it ever. Um, yeah. Now I remember why I put this one in because it's the only one that's useful. I've used it in my future classes, which is ME 131A, but or B, I forget which one. Anyway, law of cosines, next one. Okay, so the proof here, get this angle over here. So sine A parentheses equal H divided by C, and C is this one with H over here, like this. And I think I talked a lot about my cursive S, cursive T, cursive C notation for cosine, sine, and tangent that I use. Yeah, beautiful. Anyways, sine C is next. Sine C is H over A. We can figure out from here and here. Oh my god, so messy. Let me just resolve this. What does these two give me? Well, that gives me C sine A equal H and so on for the other one. What does that say? That says that because you find H over here, if you multiply H over here, you see that these are the same. Um, I'm pretty sure it's made by this guy, but later I think this guy's first. This guy is not even second, so I don't know why I put it there. Because I don't think Euclid was the one that made this. This was definitely made by someone in the Middle East, uh, because a lot of the early algebra was made in the Middle East and India. Yeah, so pretty sure that's him. Um, I don't know why I put Euclid because Euclid discovered that way later on independently, I think. I don't remember, but I was told that by someone. Don't quote me on that because I am a dumbass too, so I don't know if that is so correct. Someone can fix that for me later on. So that's the next one is this one we're trying to prove. Okay, so I dropped the angle notation because it got really annoying to write down, or basically I got lazy. But completion my ass. Okay, cosine E. So you can kind of see what we're going. We're cosine EA. Where's EA? Oh, EA. So E, and then A. What the hell am I doing? So C over here. So over here, EA. So cosine like this. So EA. Oh, that makes sense. Yeah. You get this. You get this. You understand that there's a Z somewhere that I don't know where. Oh, Z is over here. And Z equals B minus E. And then B, I guess, is the big. Okay, this is the worst notation I have. Not the worst, but one of the fucking worst notations I have ever given. Why did I think that was a good idea? Okay, now that's pretty much more clear than whatever I did previously. And clear on my drawings, please. With that, you can kind of understand this part better. We also get E because E is true over here. E is A cosine from this. So what does that mean? So cosine C equal E over A, right? And then Z equal B minus E from this thing over here. And then E is, you can substitute E over here. So it's Z equal B minus A, right? To cosine C, right? We're already getting into that form that we want, but then we need a sine C over here. So sine C from C is this thing over here, which is H equal A dot sine C. Yeah. And now here's a weird part that you're gonna need to know. Okay. So you know how this is true from the right triangle. This is why once you know about this proof, you don't look at this back because this part I guess you can know. It's not that hard to discover, but this one's a little bit annoying. Because law of cosine, I have done it like three different ways to solve it. I figured out the vector angle method from trig. I figured out this method in geometry, and there's like a three other methods that there is to get this stupid law. And then all of them are like painful. None of them are easy to get. Law of sine is pretty easy, and but law of cosine takes a lot of work. Um, so I guess you can say that the smarter mathematician is the one that got the law. I'm just joking. No, all of this is a pain in the ass. Um, because it's a lot of work because you need a lot of proofs beforehand. Anyways, where was I again? So A sine C is from here, right? You just plug it into here, and then B minus this, so over here, Z. So we have to have C square over here, the form that we wanted. We were trying to get C square. And then we get A square over here, and then we get this big equation. We're very close now. Yeah, I guess law of cosine is more useful, I guess then. All right. Not more useful, just more involved. Let's just say a lot of intensity in this one. Uh, Similar to how people say that Pontel's numbers are more intensive than the other one to figure out. Yeah, if I ever get into CFD, so you'll find that out. Most likely never will get to it because that'll take me like maybe 20 years at this point, and how slow I'm going. All right. Anyways, we get this. All right. We put it into here. Um, and then we get this big equation. Yeah, that's right. We just expand. That's a perfect square that we did last time. And so yeah, that's not it. You'll see over here that there's a sine square and cosine square, which means that this is what the fuck did I do over here? Why the fuck did I write it like this? Who the hell? Why? Just why am I this ludicrously bad at figuring out that I should that this is supposed to, why did I do this? Why? Just why? No, I was looking at this proof and I'm like, not this. Well, I must have been like at 3 o'clock in the morning or something. Like right now, I'm like 2 o'clock in the morning. So sine square c plus cosine square c. Clearly, wait a second. This is wrong. Something's wrong. Again, I did something wrong because this is supposed to be small c. Why is it capital C? Why is it capital C? It shouldn't be capital C. No, it is not capital C. Why was it capital C? This should be short c. Why is it not? Yes. And that makes this equal to 1. Small typo there. Big typo there. What am I talking about? Is it small? No, it's big typo. You don't make that big. You don't want that in a, you know, textbook I'm making. And then yeah, you can this is like from law of cosine you can figure out it. Because what law of cosine? Because you have I showed you the proof, but it doesn't mean you know what the shit that means. So let me explain what the hell that means. Um, if you have any triangle and you have an angle over here and you know the length over here, guess what? If you know the angle over here, you know angle over here. If you know a side with an angle and you know another angle, you can figure out the side over here. And if you know this angle, you can figure out the side over here from this fact because of the relationship over here. Now, with the other one, this basically means that with a side, and an angle, you can figure out the rest of the triangle. That's how I should explain it. You can figure out the rest of the triangle. With just the angles over here on one side, you can figure out the rest of the triangle, basically. And from that, you know everything. From does it congruent or not, you can figure it out. From here, we're doing the exterior angle. So this is what we call exterior angle, this part. So we know that 3x. Oh, by the way, if you didn't know, we know if you have two angles, we know the third angle because it has to be 180 if it's planar. Anyways, 3x plus 12x plus y equal 180. That's what it did, which is 15x plus y equal 180. And then it's x plus 50 plus y equal 180. Why? Because this is 180 and this whole thing, the angles will be 180, which I think I just plug into my graphing calculator and just use a system. I didn't bother doing all the math. I just used a 2 by 2 matrix because I was lazy and got this one because I was lazy. Anyways, the next part is getting the base times height. Basically, it's just some shenanigans where you just put h in and just put sine c in it, a sine c, and then you realize this afterwards. Kind of pointless, but it is some interesting fact. Oh, I didn't do this part. Okay, and I'm pretty sure this is wrong. Uh, 9/9 sure I'm wrong. That doesn't seem right. Well, I don't really remember. This is like a long time ago, wasn't it? Well, I should have done this when I was doing geometry. Well, this is a triangle area, so I will just for now we'll write t, and we know t equals all this stuff. So I'm assuming you need to get arctan, so I'll probably divide sine by cosine, which means I should get the cosine version of it. Okay, I see what you're supposed to do. Okay, I'm not doing that right now. That's a pain in the ass. Okay. I see why I didn't do it, but I'm pretty sure that's wrong. That doesn't sound right. This doesn't sound right. I'm pretty sure. I'm like 98%, 80% sure that I'm wrong. Okay, maybe 70, maybe 60. Okay, maybe less than I thought. Maybe I need to double check my own math. Okay, so this is a polynomial. Yeah, you got that right. I think. Oh yeah, I fixed this part. Basically, this is much more cleaner. I think I explained this part multiple times before. It's basically I don't understand why the hell this is a question, uh, kind of thing. What that means is like, why do I need to make it into the simplified form? No idea. In my opinion, I always thought of it like, oh, get this divided by two, get this divided by two, and then just get the middle part. I don't understand why they made me get this formula portion because it's just a waste of time in my brain cells. um, it's just geometry. Just look at it. Same with this one. Just look at it. It's kind of obvious. Anyways, that's all I've been doing. I think I'm done right now. Uh, uh, so clearly we're still on polynomials, we're still on triangles. I'm gonna move all these triangles to the triangles properties, and we'll figure it. We'll